This is year 2024. It is the geologic geometry question. We have a white rafting course. We are told that from A through B to C is level at an altitude of 60. We are told from C to D is falling uniformly of the ratio 1 is to 20. So when we multiply 1 is to 20, we get 5 in 100. So that means for every 100 meters down the river, it gets 5 meters in altitude lower. So I measured from C 100 meters or 100 millimeters up, which is point D. So at the point D, the river is 55 meters in altitude. So now we've worked out that the 60 contour hits the edge of the river here. That means this is going to be, because these contours are lower than 60, this is going to be an embankment. So I'm going to take a perpendicular construction line out within that section. We've already worked out that my units of measurement for an embankment is 7.5, so I'm going to measure out intervals of 7.5. And if the edge of the road, or the edge of, the white rafting course is 60, and this is an embankment, the first 7.5 dot will represent 55, because it's dropping 5 every 7.5. 45, 40, and I need to, no, I'll not need to go any further than that. So now, parallel to the edge of the riverside, I'm going to draw parallel lines from 55, and it hits the 55 contour there. From 50, it hits the 50 contour there. 45, it's 45 here, and it doesn't hit the 40 contour at all. It's off. So the 60 line, or the 60 edge of the river hits 60 here. 55 intersects the 50 contour. 50, 45, and then I just want you to freehand sketch 3 your points. Okay, and that is an embankment. The symbol for embankment looks like that. So imagine a puddle of water. The water will flow downhill away from this embankment. Alright, so that's that element. So next, I'll just pause this. I'm going to do the cut now along this level section and the curved section. So in order to start this, I'm going to draw a perpendicular construction through the point B, just so I know exactly where it hits the edge of the riverbank. And I'm going to draw from, and again, O is the center of this circular arc. So I'm just going to draw both of them through O, and that gives me my perpendicular. So basically, where the level section A to B ends and where the curve takes over. So I know it's a cut. We've worked out that my unit of measurements for a cut is 10 millimeters. So I'm going to take out a perpendicular construction here. In fact, we already have one, so I'll just use this as my perpendicular construction. And I'm going to measure out intervals of 10 millimeters. So if the edge of the road here is 60, well, 10 millimeters up, every 10 millimeters is an altitude change of 5 in the upward direction. So that's going to be 65, 70, 75, 80, and I think 80 is as high as I need to go. So let's just do this section first. So now I'm going to go parallel to the river's edge from 65, and it intersects with 65 there. I'll just put a dot. 70, it intersects with 70 there. 75, 80, and then the next contour, if we follow it around, is 75. So we're dipping back, but now we're actually into the curved section. So for the time being, I'm just going to freehand sketch this in between the dots. I'm just going to leave it there for the time being. Okay, so I'm just going to leave it there. Now I'm going to do the cut section within the curved area. So again, it's level, so the same heights work. So all I have to do is put my compass now on point O and take the distance from, say, 65. And just swing it round, and anywhere within this arc section from my B line to O or C line to O, does that intersect with a 65 contour? Sorry, my compass moved. Does that intersect with a 65 contour anywhere within that region? No, it doesn't. So now I'm going to go up to 70, just draw the arc and check does it intersect with the 70 contour within that region. So here's my 70 contour. No, it doesn't hit it there, so it doesn't. I'm going to go with 75. Does it hit a 75 contour within that region? Yes, it does. It's 75 here. Follow that round. It also hits it there. So you have two more intersections of my curve. And then 80. Sorry, put your compass in O, take the distance to 80. And does it hit an 80 contour within that region? This section here is 70, so no. Oh, I'm just looking here, 70 contour there. So it actually hits, the 70 arc actually hits there and there. Okay, so that means now I have those points all worked out within the curved area. So now I'm going to continue my curve down to this point. And it does, I actually have, so my 65 arc does hit 65 points. There and there. So that just gives me more points that will enable me to draw a better curve. Alright. So far that's what my cut section looks like. So not finished it yet. So what does a cut section look like? A puddle of water flowing downhill, which in this case would be towards the riverbed, the riverbank. Alright, so that's the cut section looks there. So now we have the level section complete all the way from A around to C. We're going to do the uniformly falling section now. Alright, so I always have a rule that I do at my class, and that is we cut low and we embank high. And what that means is whenever I need to do constructions for a cut, we do so on the low side, and when we need to do constructions for embankments, we do so on the high side. And between 60 and 55, of course, 55 would be the low side, 60 would be the high side. Alright, I'm going to have a quick look at this, and judging by the other side of the riverbank that's already done for us, it looks like there's going to be both a cut and an embankment, which I would expect the same here. So I'm going to start off, and I know this is going to be a cut. This cut is going to blend into this one here. So I am going to start off with the cut. We cut on the low side, which is here. So I'm going to take out a perpendicular construction, just so as I can see where the point, or the 55 meter altitude hits the edge of the road, there. And the unit of measurement for a cut is 10 mil. So I'm going to take radius 10 mil and swing an arc on the low side of radius 10 mil. And I would always annotate the radius. So in this case, or 10, radius 10. The radius 10, we join back tangential to the next 5 meter height. So from the edge of the road at 60, we join back tangentially to that radius 10. And this gives me my angle for cuts. Okay, so from that angle now, I'm going to draw out a perpendicular construction. Perpendicular construction, perpendicular to that angle for cut. My unit of measurements for cut is 10, so I'm going to measure out intervals of 10 millimeters along that construction line. The height of the river bank here is 55. This is coming from 60, so that would be height 60, or this line would represent height 60. The next 10 millimeter point would represent 65, 70, 75, 80. We don't need to go higher than that. And now setting up my set squares to go parallel to that cut angle. So anywhere it hits 60, and it hits 60 there, I'm going to put a dot. That's the only position it hits 60. Don't forget to also use your 55. So I'm also going to use the edge of the road here as 55. So it hits 55 here. Now I'm going to go up to my 65 and hit 65 here, 70, 75, 80. Alright. And now, if I have all of these points here, this is also, if we look at this contour here, this contour, if I follow it around, is a 75. So I'm also going to just follow that 75 contour to hit that point as well. And as luck would have it, it is perfectly in line with that 75. So it hits there, and it's exactly the point I have from my curved cut. So I can just continue on from there, all the way around, and stop your hard line at the edge of the riverbank, but it's always best practice to draw like a dotted line continuing on where that curve would continue. But what I also like to do now here is, no, that's okay, I'm just going to draw another cut symbol just to show that that is one large cut. Okay, I'm going to pause the video here. Okay, so I'm going to do the embankment section of this same riverbank. And how we do it is we embank on the high side. So between my 55 and 60 altitudes, 60 would be considered the high side, and my unit of measurement for embankments is 7.5. So I'm going to measure out exactly 7.5 from the edge of the river there. If you want to draw that with a compass arc, that's fine, but I'm just going to use my circles template for this. Okay, so there is a radius 7.5 arc, and again I'll always annotate or 7.5. Okay, it's just correct, or it's good practice to annotate. So we're joining a tangent from the edge of the riverbank from the low side tangentially back to my 7.5 arc. In fact, I'll just use a different colour. I'll use a different colour marker for this, just so you can see the difference between my embankment and my cut. So tangentially from the edge of the river here at 55, tangentially to my radius 7.5 arc. I'm going to take a perpendicular construction now. So going perpendicular to this pink construction line. And it doesn't matter where you draw your perpendicular. Okay, so I have my perpendicular construction line drawn. I'm going to measure out units of 7.5. So 7.5. So the edge of the riverbank here is 60. It's going from 55 here. So 60. And again 55. So this one will represent 50. And 45, 40, 35, 30, and I don't need to go lower than that. So now setting up my angle in line with the angle for my embankments. Anywhere where the 55 line intersects a 55 contour. Let me see here.
How would you get that line?
So now I'm just looking, so everywhere this 55 meter high line intersects 55, I'm going to put a dot on it. So here, one there. I'll just draw one now from my 50 heights. It's 50 there. Sorry, there actually. 45. 40, and hits 40 both here and here. And I can see now that the 45 actually hits over here also. And 50, I'll extend that over here, it hits 50 on two sides and this opposite side as well, there and there. So there are all the interval points. Now, I want one more below the road, so don't forget the center of your 7.5 arc represents height 60. So I'm also going to take that as a height 60, and it hits a 60 contour there. Okay, so now I have all the points from my embankment, so I'm going to freehand sketch through them. And what you'll notice here is, if your drawing is accurate, where it hits the edge of the road, and again I'm continuing with dots here to show where the embankment would complete, where it hits the edge of the road should be the exact same spot that your cut hit the edge of the road. So that is your embankment, and that is the geologic geometry of that river bank complete.